Welcome to Shield Spectrum. Today, we'll be exploring a fundamental yet crucial topic in ethical hacking, footprinting and reconnaissance. In this session, you'll discover how hackers gather vital information about their targets before launching an attack. And more importantly, how you can leverage these techniques responsibly as an ethical hacker to protect systems and networks. Let's dive in and unlock the first step of every successful cybersecurity strategy. Disclaimer: this video is made for educational purposes only. We do not encourage or promote any illegal activity. Today we will learn footprinting and reconnaissance. We'll explore the following key areas. Understanding footprinting concepts. Footprinting through search engines. Using internet research services. Gathering information from social networking sites. HOI's footprinting techniques. DNS footprinting techniques. Network and email footprinting. Footprinting through social engineering. Automated footprinting and AI-based techniques. Countermeasures against footprinting. By the end of this video, you'll have a clear understanding of how footprinting works, and how to defend against it effectively as an ethical hacker. Explain footprinting concepts. What is footprinting? Footprinting is the first phase of the hacking process, where an attacker, or an ethical hacker, collects as much information as possible about a target system or network. The goal is to identify potential entry points or vulnerabilities, even before making any direct contact. CEH definition. Footprinting is the process of gathering information about a target system to find ways to infiltrate it. Objectives of footprinting. So, why do hackers or ethical hackers perform footprinting? Let's break down the key objectives. Identify the system architecture and technologies in use. Detect security policies that are currently implemented. Find domain names and IP address ranges. Map out the network infrastructure. Discover employee details and internal organizational data. Reconnaissance, the first step of every attack. Reconnaissance, also known as footprinting, is the preparatory phase where an attacker collects as much information as possible about a target before launching an actual attack. This step is all about understanding the target from the outside, without alerting them. Types of reconnaissance. Passive and active. Passive. It includes open source intelligence, OSINT gathering, using proprietary databases or paid services, sharing threat intelligence with partners or industry groups. Warning: passive footprinting is generally legal, as it involves collecting information from public sources. Active. It includes DNS interrogation to reveal domain structure and records, social engineering to manipulate people for information, network and port scanning to find live systems and open services, user and service enumeration to uncover usernames, system roles, and running services. Warning: active footprinting, if done without permission, can be illegal and may lead to legal consequences. Footprinting methodology. Footprinting techniques. Passive. Footprinting through search engines. Advanced Google hacking techniques. Google hacking database. Shodan search engine. Footprinting through internet research services. People's search services. Financial services and job sites. Archive.org. Competitive intelligence and business profile sites. Groups, forums, and blogs. Dark web searching tools. Footprinting through social networking sites. Social media sites. Analyze social network graphs. HOI's footprinting. HOI's lookup. IP geolocation lookup. Active. DNS footprinting. DNS interrogation. Reverse DNS lookup. Network and email footprinting. Traceroute. Track email communication. Footprinting through social engineering. Eavesdropping. Shoulder surfing. Dumpster diving. Impersonation. Footprinting tasks using advanced tools and AI. Footprinting tools: Maltego, Reconning, Foca, OSINT framework, etc. Create custom Python script with AI. Footprinting through search engines. Search engines like Google, Bing, and DuckDuckGo are not just for regular browsing. They're powerful tools for gathering intelligence about individuals, organizations, and systems without ever touching the target directly. Let's break this down into major components. Advanced Google hacking techniques. Footprinting using advanced Google hacking techniques. Attackers use search engines to extract information about a target, such as employee technology platforms, employee details, login pages, and intranet portals, which help the attacker to perform social engineering and other types of advanced system attacks. Google hacking refers to the use of advanced Google search operators for creating complex search queries to extract sensitive or hidden information that helps attackers find vulnerable targets. Popular Google advanced search operators. Search operator purpose. Quotation marks. Minus sign. Asterisk / wildcard. Or, and. Site. File type. Related. In title. Alintitle. Inural. Alinural. Intex. Alintex. Define. Cache. 2 periods. Around X. What can a hacker do with Google hacking? Example: use Google Advanced Operator syntax, in title, intranet inural, intranet plus in text, human resources, to find sensitive information about a target organization and its employees. Attackers use the gathered information to perform social engineering attacks. Some dorks have been provided to help you find vulnerable websites. By using these dorks, you can detect whether there are any bugs between a vulnerable website and your target website. These will be useful during your bug hunting and penetration testing activities. I will post these dorks along with all other advanced dorks on my Facebook page. You can collect all the dorks from there. Here are some common Google dorks that can help you find bugs. Replace your targetwebsite.com with the address of your desired website. Footprinting using advanced Google hacking techniques with AI. AI is now a game changer for footprinting. Often, after running 50+ dorks, many irrelevant links appear. That's where AI becomes useful. Create Google Dork to find PFD files containing annual report on ecouncil.org. AI will quickly organize these for you. Use cases. Automated Google Dork creation using ChatGPT. Searching for sensitive keywords from dork results. Text summarization, understanding what information is in which link. Extracting data with AI and organizing it into Excel or JSON format. Google Hacking Database. One of the smartest methods is Google hacking or Google dorking, using special search operators to find hidden or sensitive data indexed by Google. Use cases for GHDB. Finding exposed files, e.g., .env, config.php. Camera feeds, login portals. Database files. Credentials. Directory listings. Identifying malware-infected pages. Use the inural search operator to find login pages of your target website. Simply type inural:/login site:/targetwebsite.com in the search bar, replacing targetwebsite.com with the actual domain. This will show you login pages associated with that site. Footprinting through Shodan search engine. Shodan is a powerful search engine designed for hackers and cybersecurity professionals. Target IP cameras. Let's start by finding exposed IP cameras. These are often misconfigured and publicly accessible. Target remote admin panels. Next, we search for admin login panels. These are web interfaces for routers, servers, and control panels, often left unprotected. Target VPN servers. Lastly, let's discover exposed VPN servers. These may reveal IP addresses, services, and insecure configurations. These results help us fingerprint endpoints and even find exposed portals. Other techniques for footprinting through search engines. We can use Google Image Search to find specific images related to our target. This can include photos of people, places, infrastructure, ID cards, sensitive documents, or even exposed credentials captured in screenshots. By using Google Advanced Image Search, we can narrow down the results using specific keywords, file types, image sizes, or even website filters. In addition to Google, Another powerful tool for image-based OSINT is Yandex Image Search. Yandex works really well in identifying similar faces, locations, or reverse image matching, often performing better than Google in many OSINT use cases. Image search engines like Google and Yandex can be extremely helpful for OSINT and ethical investigations. Gathering information from video search engines. Let's talk about gathering information from video and meta search engines for OSINT. First, from YouTube, you can search for any target-related video. Once you find a video, simply copy the link and submit it to a tool like MW Metadata. It will extract detailed information such as upload date, geolocation, device info, and more. This can help you analyze, investigate, or track content sources and context. Next, try meta search engines like startpage.com. If you search your target's domain or name there, it gathers results from multiple search engines, anonymously. This often reveals additional links, hidden subdomains, cached pages, or archived data not visible through Google alone. Gathering information from FTP search engines. Let's talk about gathering information using FTP search engines. FTP, or File Transfer Protocol, is used by servers to share files publicly or privately. Sometimes, due to poor configuration, these servers expose sensitive directories, including documents, backups, images, and source code. With FTP search engines like Global FTP Search, Nerdydata, or Google Dorks, you can discover open FTP servers around the world. Example: Google Dork. How to gather information using an FTP search engine. Specifically through searchftps.net. FTP, or File Transfer Protocol, is commonly used for sharing files between systems. However, many servers are misconfigured, allowing public access to sensitive files, such as documents, photos, or even source code. SearchFTPs.net helps you discover forgotten or misconfigured servers that are not indexed by Google. It's great for gathering leaked data, analyzing infrastructure, or even discovering old backups or internal documents exposed online. IoT search engines scan the internet and index publicly accessible devices, like smart cameras, routers, servers, industrial control systems, and more. These platforms allow ethical hackers, researchers, and security teams to analyze exposed systems. These queries will reveal devices connected to the internet, often misconfigured or using default credentials. You can view metadata such as IP address, location, ISP, open ports, software version, and sometimes even screenshots. These queries reveal live camera feeds, login panels, and even stream links, all without hacking, just public data. Some devices still use default usernames and passwords, making them vulnerable. Shodan is extremely powerful. But remember, this is for educational and authorized security research only. Never attempt to access, modify, or exploit a device without permission. If you enjoyed the video, don't forget to like, comment, and subscribe to the channel. I'm keeping the videos short because long videos can affect your focus. So I'll be covering the topics part by part for better understanding. That's all for today's video. In the next part, we'll explore more topics from Footprinting and Reconnaissance. Until then, take care and stay safe. Thanks for watching.